Children, today we are going to discuss chemical kinetics assignment 1 in commutative bits. So in the first question, for a hypothetical reaction, R gives rise to products. R gives rise to products. Your representation of rate is equal to minus K into concentration of R. The negative sign is used in the rate expression indicates what is the negative sign indications? Decrease in the concentration of reactant with time, decrease in the rate with time, reaction is reversible, none of the above. Which one is correct? This sign is indicated with respect to reactants, decrease in the concentration of reactants with time. That is correct answer, children. What is the negative sign indicates? Decrease in the concentration of reactants with time. Whereas with respect to products, you are using the sign is plus sign. In this case, the representation of rate with respect to products, rate is equal to plus K into concentration of products. Your plus sign indicates increase in the concentration of the products with time T. It is, that is why your negative and positive is indicate the decrease or increase the concentration of reactants or products with time respectively. So that is why you are given options. Which is correct, children? Decrease in the concentration of reactants with time is correct. So now as for options, which is correct option? Option A is correct, children. Next, in the reaction given below, what is the reaction given below? 2HI gives rise to H2 plus I2. Gas phase, it is also gas phase. Choose the correct alternative. They are asking, choose the correct alternative. Yeah, what is the first option is given? Rate of reaction. Yeah, rate is equal to minus 1 by 2. Yeah, delta H concentration of I by delta T is equal to delta H2 concentration by delta T is equal to delta I2 by delta T. This is first option given A. Second one statement is given stoichiometric coefficient of Hi and H2 and I2 are not same. You given statement stoichiometric coefficients. Stoichiometric coefficients COE, FFI, CI and TS coefficients of HI, H2 and I2 are not same. Third statement is given the rate of consumption of HI is equal to rate of 2 into rate of formation of H2 and I2. What is the thing? Yeah, rate of consumption. Rate of consumption of HI is equal to 2 into rate of formation of H2 or I2. Now the T statement is given. All the above correct statements. Now you observe, children, here with respect to reactants, always the stoichiometric coefficients, your representation in the denominator, and negative sign with respect to reactants, delta H by delta T. With respect to products, your plus sign and your coefficient is only 1. That's why delta H2 by delta T. Your I2 coefficient is 1 is equal to delta I2 by dt. So with respect to reactants and products, representation of rate is correct only. Stoichiometric coefficients. Your stoichiometric coefficient of HI is 2, but H2 and I2 are 1 and 1. That's why are not same stoichiometric coefficient. That is also correct. Third one, rate of consumption of HI. So what is the rate of consumption here? Your rate of consumption of HI is equal to minus 1 by 2 delta H by dt. But rate of formation, this current also, this side what happened with respect to 1 by 2 your delta HI by delta T is equal to here plus delta H2 by delta T. Now in comparison this one only, concentration of delta H by delta T is equal to here 2 into your delta H2 by delta T. That's why the consumption of HI is equal to the 2 into formation of concentration of H2 or concentration of I2. That statement also correct. That's why in this question option D is correct now. What is the option? All the above are correct. That's why all the above are correct statement is correct. Next, question number 3. In a reaction given as 2x gives rise to y. The concentration of x decreases. Concentration of x decreases 3 molarity to 1.5 molarities in time. Time is how much given? 4 minutes are given. Now what's the rate of reaction? So now the rate of reaction is equal with respect to reactants minus 1 by 2 dx by using 3d. That is why here 1 by 2 into change of the concentration here 1.5 minus 3 by the using of time also. How much here? 4 minus 0. That is equal to here minus 1 by 2 into here 1.5 minus 3 means minus 1.5 divided by 4. Minus into minus here plus. So that by 1.5 by 2 into 4 becomes here 8. That is equal to 0.1875 minutes. So molarity for minutes. Because of this concentration is molarity. This is about time. Molarity by minutes. Therefore, your answer is how much? Decrease in the concentration 3 molarity to 1.5 molarity. In the time of it is how much? 4 minutes. So you are using the formula rate of reaction is equal to, with respect to reactants here, 2 is their stoichiometric coefficient, 1 by 2. Here with respect to reactant using negative sign, and also here dx by dt. The concentration decreased by x is how much? 1.5 to here 3. The difference is taken here, and time is also within 4 minutes. Then if simplified, we get the 0.1875. Here minus into minus becomes what happened? Plus sign. So that is the rate is always positive children. There is no negative. Just here sign is indicate the decrease in the concentration of reactants or products with the time. So that is why. So as for options, question number 3. What is the answer? Answer A is correct children. Observe the options. Option A is correct. Next, question number 4. So question number 4, consider the following reaction. Your given reaction is 2 moles of NO2 gives rise to 2 NO plus O2. If rate of disappearance of NO2, rate of disappearance of NO2, they are given as rate of disappearance of NO2 is equal to 6 into 10 to the power minus 12 molarity in seconds. Then asking the rate of appearance. Rate of appearance of O2 is equal to how much? That is the question. Now your comparison of NO2 and O2 children. Now write about rate expression with respect to NO2, your minus 1 by 2. The concentration of NO2 by dt is equal to your plus your D concentration of O2 by dt. Here given rate of disappearance of L is how much given? 6 into 10 to the power minus 2. That is why here 1 by 2 into 6 into 10 to the power of minus 2 minus 1 is equal to here d into d42 by dt. Therefore here how much? Therefore concentration of your rate with respect to O2 is equal to how much? 3 into 10 to the power of minus 12 molarity per seconds. So that is why answer is how much? 3 into 10 to the power of minus 12 molarity seconds inverse or per seconds. This is about the fourth question. This also how much answer? 3 into 10 to the power of minus 12. Answer becomes how much, children? Answer A is correct. So what is asking here? Rate of disappearance of NO2 is given, but asking rate of appearance of O2, because O2 is a product, that's why appearance. NO2 is a reactant. Concentration of NO2 what happened? Progress of the reaction disappearances. So that's why the comparison of NO2 and O2 with respect to rate using the formula is fine. Now we are finding out the appearance of rate of O2. You are given disappearance of rate of NO2 value 6 into 10 to the power minus 1. As for stoichiometric coefficient, it becomes here 1 by 2. Therefore, simplified, you get the 3 into 10 to the power minus 12 molarity per second. Next, question number 5. Question number 5. For the reaction, the given reaction is of 5Br minus BrO3 minus 6H plus gives rise to 3Br2 plus 3H2O. This is the given reaction. In given conditions, if dBr minus by dt, your minus sign is equal to as K1, your Br minus given as K1 Br minus. Next is given as BrO3 minus by dt is equal to K2 Br minus. Next Br2 by dt is equal to K3 Br minus. Now asking then what is the relations of K1, K2 and K3 related as? What is the relation between K1, K2, K3? By using these expressions. First item of the given reaction, expression of rate. So what is rate, children here? With respect to reactants, minus 1 by 5 Br minus by dt is equal minus BrO3 minus by dt is equal minus 1 by 6 dH plus by dt is equal plus 1 by 3 dBr2 by dt is equal to plus 1 by 3 dH2 by dt. This is expression rate with respect to reactants as well as products. Here given as minus Br by dt is equal to how much then? K1 Br minus 1. Therefore here write about 1 by 5. This term is 1 by 5. 1 by 5 is as minus Br by dt place. You write about K1 Br minus. Next given minus dBr3 by minus 1. This term is given as K2 Br minus. Next is given as next one. Which one? Br2. So what is the Br2 term? Yeah, 1 by 3. 1 by 3. dBr2 by dt is equal to K3 Br minus. Now children observe here, all are terms are here, K1, K2, K3 terms are there. Now we take the here Br minus term, Br minus term, Br minus term is cancelled. Then what is the remaining? Here K1 by 5 is equal to K2 is equal to K3 by 3. So now can take here LCM. How much here? It becomes LCM is 15. In cross multiplication, how much here? This applies. This one right about 3K1. It right about 15 K2. It right about 5 K3. So here 3K1 is equal, 15K2 is equal to 5K3. So now here also simplify here, cancellation by 3, 3 1 3, 3 5 15, here again 3 1 here 1.66 K3. Therefore final answer here K1 is equal, here 5K2 is equal 1.66 so K3. So this is the correct relationship between K1, K2 and K3. So now, children, first we are given the terms right now with respect to rate of the reactants as well as products. Now we have substituted the value minus Br minus 1 by dt is equal to right about K1 Br minus. Next about here minus D Br over K minus by P is equal to right about the term K2 Br minus term. Next we are given dBr2 by dt is equal to K3 Br minus. But in this equation, what is the term is there? Plus 1 by 3. Instead of dBr2 by dt, write about K3 Br minus. So now, in all the cases here, Br minus is cancelled. What about remaining? K1 by 5. Here becomes K2 only. Here K3 by 3. So K3 by 3. Now can take here. LCM is how much? 15. Therefore, here becomes equal to 3K1. This becomes equal to 15K2. This becomes equal to 5K3. So therefore, the ratio is how much here? 1 is to 5 is to 1.66. That's why the simplest ratio here, relation is K1 is equal to 5K2. That is equal to 1.66 K3. So as for options, the 50% children, option A is the correct answer. Next, so next question number 6. In question number 6, is given as the factors affecting the rate of reaction are. What are the factors affecting the rate of reaction are? Temperature, pressure, concentration of reactant or products, catalyst. Which is correct, children? Factors affecting the rate of reaction. One of the factor, temperature, concentration, catalyst, and pressure. For gaseous reactions is also influenced by the pressure factor also. So these all factors are influenced the rate of reaction. That's why we are given options as per options. So all of this is correct. That is question number D is our answer, children. Next, question number 7. The temperature coefficient of the reaction is. Temperature coefficient of the reaction is. What is temperature coefficient? The temperature coefficient of the reaction is the mu is equal to, you write about 3 degrees centigrade plus 25 degrees centigrade by 25 degrees centigrade. This is the ratio of the two temperatures differ by 10 degrees Celsius is called temperature coefficient. So here temperature using about 10 degrees Celsius temperature is using. So if Tc is equal to how much? 10 degrees Celsius. Therefore, what happened here? Temperature difference is how much? It becomes 35, it becomes 25. 35 by 25. The difference is how much? The ratio of the two temperatures, 10 Celsius degrees. That is why here the temperature coefficient means the ratio of the two temperatures, difference is 10 degrees Celsius, is called temperature coefficient. So now we are given the procedure, the ratio of rate constant at two temperatures, the ratio of root constants differ by 10 degrees, preferably 35 and 35. 25 and 35. Next, the rate constant is a fixed temperature. At a fixed temperature, none of the above. So now the temperature coefficient means the ratio of the two temperatures differ by preferably 10 degrees centigrade. We are using the temperatures of preferably 25 degrees centigrade and 35 degrees centigrade. So that is why it becomes what by 35 degrees centigrade by 25 degrees. So in between difference is 10 degrees Celsius only. That is why your option B is correct, children. Next, in zero order reaction, for every 10 degrees rise of temperature, zero order reactions, for every 10 degrees rise of temperature, rate is double. If the temperature is increased to from 10 degrees centigrade to 100 degrees centigrade, the rate of the reaction will be. So what is it meant? Zero order reactions, for every 10 degrees centigrade rise of temperature, rate is double. So every 10 degrees rise of temperature, rate becomes double. Rate becomes how much? Double. So if the temperature rises from 10 degrees centigrade to 10 degrees centigrade to 100 degrees centigrade temperature. Next asking, the rate of reaction will be. Rate of reaction will be. So children here, observe here. Yeah, 10 degrees centigrade ignition is there. 10 to 20, 20 to 30. 30 to 40, 40 to 50, 50 to 60, 60 to 70, 70 to 80, 80 to 90, 90 to 100 degrees centigrade. Here every 10 degrees rise of temperature. How many times rises here? 1, 2, 3, 4, 5, 6, 7, 8, 9. So how many times are rises here? 9 times rises of temperature. Here given rate is every 10 degrees temperature rises double. There. So now see children, every 10 degrees rise of temperature, rate of reaction becomes double. But temperature changes from 10 degrees Celsius to 100 degrees centigrade. That means how many times are rises here? 9 times are rises. You are using the formula 2 to the power of n. N is called number of times rise of temperature. That's why 2 to the power of 9 is equal to 512 times. That is the rise of temperature. We are increasing of the rate of reaction will be how much here? 512 times. So that is about the answer here, 512 times. Next question, we are given the graph of representation, fraction of the molecules versus kinetic energy. This is about the distribution of the curve showing the energies. So this is the peak of the curve. This peak of the curve is to indicate here which type of energies. Most probable energy, activation energy for forward reaction or activation energy for backward reaction cannot be predicted. So this is indicate the most probable kinetic energy of the reaction. That means here most of the molecules is exhibits the energy is called most probable kinetic energy. In a given sample of a gas, here different molecules are having different kinetic energies. But in average, your maximum number of molecules here consisting of the energy is called most probable kinetic energy. That is here indicated the peak of the curve. So now, as for options, which is correct answer here? Question number 9. This is regarding question number 9. It is about the answer. A is correct. Next one. Which of the following statements explain the role of catalyst increasing the rate of reaction? You are given 4 statements. Which statement is explained the role of catalyst? The first statement is catalyst provides alternative path of lower activation energy of the reactants. Next, it decreases the rate of backward reaction. It increases the number of collisions between the reactant molecules. It provides the extra energy to reacting molecules. Here, always the catalyst is provides the alternate path of the reaction as well as decreasing of activation energy, increasing of rate of reaction. That is the function of catalyst. What are the functions of catalyst here? Increasing the rate of reaction, decreasing the activation energy, change the path of the curve. That's why here given options, here the catalyst provides alternative path of lower activation energy to the reactants. That is why here choose the correct option as per your options. 10th one is 11th answer correct children. Next 12th one. Here also on the basis of the curve shown identify the incorrect statement. Here given graph is of potential energy versus reaction coordinates. Reaction coordinates. This is the shape of the curve is given. So these are the reactants, these are the products, and one more curve also given, dotted line curve. So now this is a reaction path with catalyst. This is a reaction with a reaction path with catalyst. So this one is a reaction path without catalyst. Without catalyst. So this is called energy of the activation. EA, energy of the activation. So now ask the question on the basis of your graph. Catalyst provides alternative path or reaction mechanism. It increases the activation energy between reactants and products. It lowers the potential energy barrier. Catalyst reduces the activation energy between reactants and products. So now, which is correct here? So now, here, choose the correct answer is about your catalyst provides the alternate path of the reaction. So that is why here taken as increase the activation energy between the reactants and products. Now, here what happened? Here catalyst provides alternative pathway of the pathway or reaction mechanism. So observe here, without catalyst, the shape of the curve like this. With presence of the catalyst, the dotted line. Then what happened here? Decreasing of the activation energies as well as change the path of the curve. That is why here catalyst provides alternate path, way or reaction mechanism, but not increase the activation energy. Always decrease the activation energy. So that is the correct answer here. Only alternate path of the reaction. Next. So now this is the answer. B is correct. Sorry, the answer B is correct. Next one. Question number 12. A catalyst has no effect on. So what is the function of your catalyst? No effect on rate of reaction, equilibrium constant of reaction, Gibbs energy, activation energy. So here not effect on here which one? Equilibrium constants, and also here Gibbs energy also. there is no effect on catalyst of your equilibrium constant to Gibbs energy. That's why catalyst there is no effect of the equilibrium constant as well as Gibbs energy. But your effect of rate of reaction, activation energy. So what happened? Rate of reaction increases, but what happened? Activation energy decreases. So that's why this no effect on equilibrium constant and Gibbs energy. To answer that is the question number 12. Answer is choose as D option. So that is children. Today we are going to discuss up to these bits.